Object-oriented programming. Object-oriented programming is a programming paradigm that uses objects to design and structure software. In Swift, object-oriented programming is implemented using classes and structures. This particular video will cover the basics of object-oriented programming, including classes, structures, properties, and methods and inheritance. Now let's jump into it. The first thing that I want to cover is classes and structures. Now, both classes and structures in Swift can define properties, constants and variables, and methods, which are functions. The key difference in that is that classes support inheritance, which means they can inherit properties and methods from other classes, while structures cannot. Let's look at an example in this particular case. So for classes, I'm going to create a class person. This is how you create a class, and inside this I want to give a couple of parameters: name, which is a string. I have age, which is an int. Next, I want to create an initialization method. I can say init. So as you see, class has no initializers. It's already complaining. So I'm going to create the initializer. It automatically helps me. This Xcode does help me create it. So this is how you create an initializer with name, age, where self.name equal to name, self.age equal to age. And then if I want to create some methods inside it, like let's say the greet method, I can say here print hello, my name is whatever the name is, and I am so whatever my age is years old. Hopefully there's no one with 1 year, so it doesn't have grammatical issue here. But that's how you create a particular class. Now if I want to call this, let's say Alice equal to person. Now it gives me these parameters to initialize this. I can say my name is Alice and my age is, let's say, 38. So what it does is it creates a person object, and it looks for a function, initializer function, which uses name and age, which is here, and it assigns the value as name and age. So if you call the greet function on this by saying Alice dot greet, what it will do is it will say hello, my name is Alice and I am 38 years old based on the values we have passed here. So this is how classes work. Now let's look at how a structure works. I'm gonna get rid of this. Let's look at a structure. Now structure starts with struct. I'm going to use another traditional example of a book where I have title is string and author is another string. Now I don't have to create an initializer method here. Description, like in what is it, what do you call it, classes, and I have a description here, function description method here, which says return. Why am I putting not a print function? Say slash title by author. And now if I want to create a book structure, I can say book equal to book. If you see, it automatically gives me those initialization functions without even doing anything. Let's use one of the books called as 1984. Author of that book was George Orwell. And now I can just say print, I don't need this, book dot description, and I run it. It will go through this. I don't have to create an initialization method in this. So this is how you create a structure. So that's all about classes and structure. Let's look at properties. Now properties are values associated with a class or structure. They can be stored properties like constants or variables, or computed properties that calculate a value. So let's look at example of a stored property where I have a class car which has three variables: string, make, model, and you got it right here, which can be an integer. Of course, I have to create an init, and it helps me do it automatically. That's the best part about Xcode. And now, sorry, if I want to create let car equal to car, and I'm going to say make is Tesla, model is 3, and year is 2023. Now I can say print car is car dot make, then can say car dot model, and the year is, actually let's start with year, car dot year. Now if I run it, so all these properties that we have here, make, model, and year, it automatically, it kind of stores, these are the stored properties that we have for this particular class. Now let's look at the computed properties with, let's do it with a struct, and I'm going to call this struct, let's use rectangle, the shape rectangle, and a rectangle shape has, let's say, width, double, and has a height, which is also double. Now area, which is a double, return width times height. So if you see what I'm doing here, I have width and height, and area, which is a computed property. Let rectangle equal to rectangle, and inside that I'll give width of, let's say, 5.0 and 6.0 for height, and I'll say, oh, not private but print area, which is a computed property, comes from rectangle dot area. If I run it, I should have 6 times 5, which is 30, which is the area of the rectangle. So this is how you can have computed properties. So we're done with properties. Next, let's move on to methods. Now methods are the functions inside a class. Methods are functions that belong to a class or structure. Instance methods operate on instances of the class or structure, while there's type methods that are associated with the type itself. So what do I mean by that? Let's look at some instance methods in class. Let's create a circle class, and inside this I have radius, which is double, and then I have initialization method, and then I create a method function circumference, if I typed it right, double, which is return. Now the circumference of a circle is 2 pi times radius. Pi is actually a math operator that is already available in Swift, so you just have to say dot pi and it works, which is amazing. And now I can create a circle instance and say circle of radius, let's say 5.0, it's a double. I'll say print, and inside that I'll say circumference is circle dot circumference. Now if I run this, I mean, I don't want to do the math of this, 2 times pi times radius, but I assume it's right. So that's how you can create like instance methods inside your class. Now let's look at type methods. So I have, let's say, a class which is called math, since I'm so good at math, as you realize by now. And inside that, I create a class func square. You probably have not seen this in other programming languages much. Number is of the type int, and return number times number. This is more like I'm squaring. Uh, so this is a type method where you start with class and you assign that value, and I think since I'm returning int, I have to have the return type. Now if I print square of 4 is, just to everything here, I can say math function, math dot square. Since it's a class function inside, I can directly call by the math method. Now you probably worked with class functions in other programming languages. If not, this is how it works. You don't have to create an instance of a particular class. You can directly call the class methods straight away. 4 times 4 is 16, and that's what we get here. So these are helpful, sometimes called as type methods, sometimes called as class functionality or class methods. That's how you do it. Now that we're done with methods, let's look at inheritance. Now inheritance allows a class to inherit properties and methods from another class. The class that inherits it is called a subclass, and the class being inherited from is called a superclass. Let's look at an example. So I create a class animal. Now this animal has a name, call it of the type string. Okay, next I need an initializer, which it automatically makes it for me. Create a method called as make sound, and I'll say print. By default, I'll just say some generic sound it makes. Next, I'll create another class called as dog, which is an animal. So here I'm inheriting. What I'm saying is I want to create a class which inherits all the properties and function or methods from a particular class, which is animal. So I don't need to create a name for it. Because animal has it, it also has a name. It has make sound, which I typed wrong. Make sound function available. Now if I want to override this, override func make sound, which means I don't want to use the parents method. I want to create my own method. And what does the dog do? It barks. So now when I create, let's say, an dog object which is of the class dog with the name, let's say, buddy, and dog dot make sound, what it will do is it will call the overridden method with this bark. Now similarly, if I create another animal, I'll say cat equal to animal name, call it meow, or actually let's not confuse it, cat is Betty. Now if I say cat dot make sound, since it doesn't have any other class that inherits it, it's just going to use the animal and say make sound. Similarly, I can create a cat without overriding, and I can just say this is cat, and everything will work the same way as before. I can create another function inside here, more methods inside here, but this is how inheritance works in Swift. Now that we completed object-oriented programming, let's create a brand new project from scratch and learn all these things that we did in one single project. So I'm going to create a class student which has name as a string and grade as an int. We'll create an initializer method which automatically gets created. Function, I'm going to say description, which returns back a string where it says return name is in grade. So it's not about your grade marks, but it's all about which grade you are in. So let's say I want to create a student object with the student class, and that student's class name is John, and John is in 5th grade. I can just say John 5th. Print, I can say student dot description. Now if I run this, it will say John is in grade 5. So that's perfect. Let's create a structure. Structure point. Now point has two parameters or two the properties. Double variable y is also double. So point has coordinates x and y. That's what it is. And since it's a struct, I don't have to create a initializer method. So directly go to distance to a particular point needs point object which returns back double, that gives me the distance to a particular point, where I say let dx equal to x minus point dot x, and then I'll say same thing for y coordinate, dy equal to y minus point dot y, not minus, and then this will return back dx times dx plus dy plus dy times dy, dx times dx plus dy times dy dot square root. That's a built-in functionality that we can use. Okay, let's make sure everything is perfect. And now we'll create that point. Let's create 2 points. Point A equal to point x is, let's say 3.0 and 4.0. Let's create point B, which is point xy 6.0 and 8.0. Now let's look at the distance between the two. I just give some random values. So distance is slash point A dot distance to point P. This should work. Let's run it. Distance is 5.0. So it kind of gives me distance between 2 points. Perfect. Using struct. Now let's do a class subclass. Let's say I have a class which is a vehicle class, my favorite one, which has property of speed, which is of the type double. Now I can initialize this. Perfect. Let's create a function description. And that returns back a string where it will say return traveling at whatever speed was passed or whatever speed was set miles per hour. Now next, once this is done, let's create a class, the fastest vehicle bicycle, which is of the type vehicle. So I'm inheriting from vehicle. So it gets all its property. I'm going to create another properties has basket or not, because sometimes your bicycle has a basket. So it's yes or no. And I'll initialize for this has basket, which says self has basket, but I will also have to call the super class, because I'll have to initialize that with a speed of speed, which means I'll have to use pass speed here too, just to make sure that it doesn't break my super init function. Once that is done, I can override the description function that we created, which returns a string, where I'll say return super dot description. So whenever you call super is the master class, which is in this case the vehicle class, plus I also want to say with a basket has basket. So it will say if it has a basket or not. Let's use this. I'm going to say let bike equal to bicycle, which is going at a speed of, let's say, 15 miles per hour, has a basket, let's say true, and then I can just say print bike dot description. Let's run it. And if you see here, traveling at 15 miles per hour with the basket is true. I can pass false and it will accordingly change that to false. Now, sorry, you learned about classes and structures and their differences. We also explored properties, including stored and computed properties. We practiced defining and using methods, both instance and type methods. And we also understood inheritance and how to create subclasses. Now, object-oriented programming is a fundamental concept in software development. The next section will cover protocols and extensions, which allow you to define blueprints for methods and properties, and to extend existing types with new functionality. That's how it's supposed to be done for modularity. If you have any questions, do let me know in my comments, and stay tuned for the next one.